Hi, I'm WangJiarui, matric number 165409. Welcome to my final year project, Smart Library, an image recognition lending system powered by MobileNet v2, PaddleOCR, Flask, and MySQL. This project is supervised by Mr. Tan Fit Huan and examined by Associate Professor Dr. Koo Hee Koi. Let me walk you through it. Ever since libraries came into existence, one challenge has always sat at their core: managing the lending and returning of books. As collections grow into the thousands and tens of thousands, keeping track of every single book, who borrowed it, and when it's due, becomes a surprisingly difficult and important problem. Over the years, two main technologies emerged to solve this. The first is the traditional barcode circulation system, a printed label on every book scanned at the counter. The second is RFID, a more advanced but far more expensive method that embeds an electronic tag into each book. For decades, libraries have relied on these two approaches to handle borrowing and returning. But here's the question worth asking. If libraries keep relying on these traditional methods, will problems start to appear over time? As it turns out, yes, several of them. Libraries are at the heart of education, giving students and readers access to knowledge every single day. But behind the scenes, the way books are actually lent out still faces some real problems. The current methods are often slow, unreliable, and surprisingly costly. Picture a typical library. Thousands of books line the shelves, each one waiting to be borrowed and returned. With a collection this large, managing every single loan quickly and accurately becomes a real challenge. The most common method is the traditional barcode. It's cheap, but it's also slow. During peak hours, readers are forced to line up and wait, while a librarian scans each book one at a time. Every barcode needs a clear line of sight, and a single faded or damaged label can stop the process entirely. It simply doesn't scale when the library gets busy. The alternative is RFID. It's fast and convenient, allowing several books to be processed at once, but it comes at a steep price. Every single book needs its own electronic tag, and the library must install dedicated scanning gates and readers throughout the building. For many libraries, especially smaller ones, these costs are simply too high to justify. So when we put the two side by side, the trade-off becomes clear. Barcodes are cheap, but fragile. They need a direct line of sight, they fail on faded labels, and they can only handle one book at a time. RFID, on the other hand, is fast, but expensive. It needs an electronic tag on every book, along with dedicated gates and readers. In short, no existing solution successfully balances efficiency with affordability. Libraries are forced to choose between a system that is cheap but slow, or one that is fast but costly. And that gap is exactly where the need for an innovative new approach becomes clear. That's exactly what Smart Library delivers. The key idea is simple but powerful. The book becomes its own identifier. Instead of relying on a fragile barcode or an expensive tag, the system recognizes a book directly from its cover using AI. This makes it resilient, since there's no label to damage. Cost-effective, since it needs no RFID tags. And it requires no retrofitting. It works with a library's existing books and infrastructure as they are. Under the hood, Smart Library is built on a comprehensive technology stack. At its heart is the AI recognition engine, powered by MobileNet v2, which drives accurate and efficient book identification. A second engine, PaddleOCR, seamlessly extracts book information like title, author, and ISBN straight from a cover photo. And the backend, built with Python Flask, powers a robust API that ties every operation together with the MySQL database. The project is built around 6 key objectives: to design a high-accuracy AI recognition engine, to automate borrowing and returning with no manual entry, to ensure real-time data integrity for every transaction, to cut the average transaction time by 50% or more, to provide intuitive user interfaces along with cataloging assistance, and finally, to prove the entire system can run on affordable, commodity hardware. Here's an overview of how the system is organized into 4 main modules. The image acquisition module captures the book's image using a standard webcam. The recognition engine uses AI to identify the book without any labels. The transaction management module automates borrowing and returning safely, even under concurrent access. And the catalog and communication module powers searching, recommendations, and announcements. All of this rests on a clean 3-layer client-server architecture. The presentation layer provides a user-friendly web interface that runs in any browser. The application layer hosts the Flask API, which handles all the business logic. And the data and intelligence layer manages the AI recognition models and the MySQL database. This separation keeps the system organized, scalable, and easy to maintain. Let's look at each layer more closely. The first is the presentation layer, the part you actually see and use. It's a simple, user-friendly web page that opens in any browser, on a computer, a tablet, or a phone. The reader just points the camera at a book, and the clean design takes care of the rest. There's no app to install, and nothing complicated to learn. The second is the application layer. Think of it as the brain in the middle. It runs on Flask, and it handles all the logic. It checks who is logged in, decides whether a book can be borrowed or returned, and talks to the database. Whatever the user does on the screen, this layer makes the right thing happen behind the scenes. The third is the data and intelligence layer. This is where the smart work happens. The AI model looks at the book's cover photo and recognizes which book it is. The MySQL database then stores everything, all the books, users, and loan records. Together, they give the system both its memory and its intelligence. Now let me walk you through how the system is implemented. Smart Library uses a clean 3-layer client-server architecture, and I'll trace it the way the data flows. It begins on the left, in the client layer. The user holds a book in front of a standard USB webcam, accessed through the browser with WebRTC. The web interface, built in Jinja 2, HTML5, CSS3, and JavaScript, runs an auto-capture algorithm in the HTML5 canvas. Every quarter-second it converts the frame to grayscale, applies a Sobel gradient, and checks for stability, then auto-captures after a short countdown, so the user never presses a button. That image is sent, step A1, as an HTTP post into the application layer, a Python Flask server. At its heart is the transaction controller, built on SQL Alchemy, where every borrow or return runs inside a select for update row lock, so two readers can never take the same copy at once. Access is guarded by role-based authentication using WorkSug scrypt hashing. The controller then calls the data and intelligence layer. In step A2, the recognition engine, a mobile NetV2 convolutional neural network in TensorFlow and Keras, identifies the book. It is trained with two-phase transfer learning. First, feature extraction with a frozen ImageNet backbone, then fine-tuning of the top 30 layers at a much smaller learning rate. In step A3, the controller updates the MySQL database, and in step A4, a JSON result returns to the browser to confirm the loan, all in under 4 seconds. Two supporting flows complete the picture. Flow B is cataloging. A new book's cover goes to the PaddleOCR engine, which auto-extracts the ISBN, title, author, and publisher. Flow C is offline retraining. The pipeline reads the reference images, applies 50 times augmentation, a stratified 70-15-15 split, retrains, evaluates on a held-out test set, and redeploys the model, all from one admin button. And the key point, it all runs on nothing more than a standard webcam and an ordinary PC. Zero special hardware, zero retrofitting, zero per book cost. Now let me demonstrate the system from the administrator's side. On the login page, I enter the admin username and password. This account gives me full access to manage books, readers, and the recognition model. And it loads straight into the main borrow and return page. This is the book cataloging page, where the librarian adds brand new books into the system. To begin, I click the Add Book button at the top. The camera opens, and I hold the book's cover up to it. Just like on the borrowing side, the system scans the cover automatically. But here, instead of looking up an existing record, it captures the cover image as training data for a brand new book. I hold it steady, the auto capture takes the shot, and the cover is recognized and captured successfully, ready for the details to be filled in. Now I fill in the book's information. The system supports many detailed fields, including the ISBN, category, publisher, language, and physical shelf location. For this demonstration, however, I'll simply enter the two most essential details by hand, the book's title and its author, to keep the walkthrough quick and clear. I click Confirm. The book is cataloged instantly, and a clear success message confirms it has been added to the collection. I then head back to the main page. Next, I add a second book, following exactly the same process. I open the cataloging page once again, click Add Book, and hold the second cover up to the camera so the system can scan and capture it. Once the cover has been captured, I type in the title and author just as before and click Confirm. The book is added successfully, and this time the system automatically takes me straight to the library, where the new entry now appears. Now for the third and final book. Once more, I open the cataloging page, click the Add Book button, and present the cover clearly to the camera so it can be scanned and captured as well. As with the others, I fill in the title and author, then click Confirm one last time. The third book is cataloged, and the system again jumps to the library. So in just a few minutes, I've added 3 brand new books, and each one has had its cover captured as fresh training data that will later be used to teach the recognition model to identify it on its own. Back in the library, I can now see all 3 newly added books in the catalog, each with its cover, title, and author. Finally, I retrain the recognition model so it learns the new books. Already in the admin panel, I click the Retrain button. The system takes the cover images and trains the MobileNet V2 classifier in the background. Within moments, training completes, and the updated model is deployed automatically, ready to recognize them. Welcome to Smart Library, an intelligent book lending system powered by image recognition. This is the login page, a clean and secure entry point for both readers and librarians. Let me begin by showing you how a brand new reader signs up for an account. I click Create One to open the registration page. Here I enter a username, choose a secure password, and then confirm it by typing it once again. The form validates every field in real time, making sure the 2 passwords match and the username hasn't already been taken by another user. Once all the details are filled in correctly, I submit the form and the new account is created instantly. Registration is successful, and the system automatically returns me to the login page. Now I can sign in with the account I just created, simply by entering my new username and password, and then clicking the Sign In button below. And just like that, I'm taken straight into the main Borrow and Return page. This is the Borrow and Return page, the heart of the whole system, where a book's cover is scanned to borrow or return it. Now let me open the home page. Home is the reader's personal dashboard. It greets you by name, displays your live borrowing statistics, shows a scrolling bar of the latest announcements, and presents a grid of recommended books, each with its cover and shelf location. Next, I move into the library module, the system's full catalog. Readers can search by keyword, filter by category, and browse page by page. Clicking any book opens its detail page, showing the author and where to find it on the shelf. Finally, the Announcements module. Here, readers see every library notice in one place, from system updates and upcoming events to important reminders, all categorized by type so nothing important is ever missed. From the Announcements page, I head back to the main Borrow and Return page. I click the Borrow button, the camera opens right away, and I hold the book steady inside the frame. The auto capture feature detects the cover and takes the photo on its own. Recognition succeeds in just a moment. The confirmation screen appears, clearly showing the book's title, the borrow date, the due date 30 days from now, and any overdue days. I click Confirm to continue. Back on the main page, the My Loan section now lists every book I currently have on loan, clearly showing the title, the borrow date, the return due date, the number of overdue days, and a Renew button to extend the loan whenever I need to. Now let's see what happens if I try to borrow that very same book a second time. I click Borrow again and scan the identical cover. This time the system immediately responds that the book is unavailable because it is already out on loan. This safeguard prevents the same physical copy from being borrowed twice at once. Next, I open my personal profile by clicking the reader avatar in the top right corner. This page gives the reader a complete view of their entire borrowing history, listing every past and current loan, along with personal statistics and their own category preference settings. Now let's return the book. I head back to the Borrow and Return page and click the Return button. Once again, I hold the same book up to the camera and the system scans its cover. After just a couple of seconds, the scan completes and the book is recognized successfully. The system then processes the return, updates the record in the database, and I click Confirm to finalize it. Returning to the main page, I open my personal profile once more to verify the final result. And there it is. The loan has now been closed and neatly moved into my borrowing history, confirming the return was processed correctly. Finally, I open the library one last time to check on the book itself. Its status has now switched back to available, ready for the very next reader to borrow. And that completes the entire borrow and return cycle from start to finish. Beyond its technical design, Smart Library is built to create real social impact, aligning with 3 of the United Nations Sustainable Development Goals. First, quality education, Goal 4. By automating the lending process, our system removes barriers and lets students access knowledge quickly, supporting lifelong learning and educational equity. Second, industry innovation, Goal 9. By replacing fragile barcode and labeling systems with advanced AI recognition, we offer a cost-effective solution that drives technological progress while making the most of existing infrastructure. And third, reduced inequalities, Goal 10. Because the system runs on affordable, everyday hardware, it ensures fair access to education for all, helping to bridge the digital divide and empower underserved communities. To bring Smart Library to real institutions, we have designed a 3-tier commercialization model. The Community Edition is completely free and self-hosted on the library's own computer, giving smaller libraries the essential features they need with no upfront cost. The Pro Edition is a subscription service that adds cloud hosting, automatic nightly retraining of the recognition model, and comprehensive analytics dashboards for smarter library management. And the Enterprise Edition offers custom deployment for large, multi-branch libraries, with priority support and tailored integrations built around each organization's specific needs. Looking ahead, we have 3 key goals for future development. First, scaling. We aim to add an approximate nearest neighbor index to the recognition engine, allowing the system to manage and identify tens of thousands of book titles quickly and efficiently. Second, mobile. By developing a native mobile application, we will let users access library services anytime, anywhere, delivering true 24/7 self-service and far greater convenience. And third, batch detection. We plan to introduce batch multi-object detection, so users can check out several books at once, dramatically reducing transaction times and improving the overall experience. That brings us to the end of our presentation. Thank you very much for your time and attention. We hope Smart Library has shown how image recognition can make book lending faster, smarter, and more accessible for everyone.